Hi everyone. Welcome back to part 2 of Cisco Secure Firewall Threat Defense Virtual Cluster with Autoscale series in AWS. My name is Greeshma, working as a technical marketing engineer at Cisco Systems. This is part 2 of the video. In part 1 of the video, we explored the core concepts. We spoke about virtual firewalls, we spoke about clustering, auto-scaling, target failover, and the overall architecture and the traffic flows, etc., etc. Right? If you haven't watched that video yet, I recommend checking it out first to get the full context before continuing with this hands-on walkthrough. I'll add the link of the video in the description box below. Do check it out first. So talking about this video, in this video, we'll see how to deploy Cisco Secure Firewall Threat Defense Virtual FTDv cluster with auto-scaling in AWS and also validate the deployment, right? So this video targeted mainly for cloud and network security engineers, firewall administrators, and anyone who is looking to deploy FTDv clusters in AWS with auto-scaling. It's also useful for DevOps and automation engineers who work with AWS CloudFormation or any automation tools and wanted to understand how this solution is deployed and scaled. Even if you are new to this setup, this video will help you get a clear picture of how all the components come together from deployment to validation. Okay, we'll go step by step, starting from the prerequisites and AWS setup to launching the firewall instances, forming the cluster, configuring the gateway load balancer, enabling auto scaling, and finally validating the deployment. So let's get started and see how to bring this powerful cluster and auto scaling solution to life in AWS. Okay, first things first. So there are two ways to deploy the cluster with Autoscale in AWS. First one is a manual deployment method where you manually deploy and configure everything step by step. And you will need to create and set up all the AWS resources manually, like including VPCs, subnets, security groups, network interfaces, gateway load balancers, gateway load balancer endpoints, target groups, and firewall instances, and forming a cluster, onboarding them to the FMC, etc., etc. So you can follow this approach if you are well versed with AWS and its services, and also with the firewall configurations. And also if you would like to deploy and configuring everything manually, you can follow this manual deployment method, right? So the second option is the template-based deployment, where Cisco provides pre-built CloudFormation templates that automatically create and configure the required AWS components for you, like the VPCs or the subnets or the network interfaces, firewall instances, load balancers, target groups, and even the auto scaling setup, right? So in this video, we'll follow the template-based deployment method. And if you prefer to deploy manually, I'll add a link to the detailed step-by-step documentation in the description below. So feel free to check that out. You can follow that guide and can deploy the same solution manually. But here for this video, we are going to use the template-based deployment. All right, let's get started with the first step of the deployment, which is downloading the CloudFormation templates provided by Cisco. As I mentioned, Cisco provides a set of pre-built AWS CloudFormation templates that automates the complete deployment of FTDv cluster along with auto-scaling. These templates handles everything from creating all the AWS resources, like to deploying the gateway load balancer, target groups, auto scaling groups, and also the FTDv instances themselves, right? So you can find these templates in this Cisco GitHub repository. I'll leave the GitHub repository link in the description box below. You can either clone the repository using Git, or you can just simply download it as a zip file. Here I'm downloading it as a zip file. Click on download zip. It will download the zip file into your local machine, right? Okay, now we've downloaded the templates that we need to deploy this solution, and we have a few other prerequisites that we need to complete before going further. We need to have one FMC, Firewall Management Center, to manage our firewalls. You can either use the existing FMC or can deploy a new one, right? Okay, so I already deployed one FMC in AWS. So we'll be using this FMC for this deployment. So let's just quickly log in. So here on the FMC, first we need to create one access control policy. To create access control policy, click on Policies and Access Control. Here, click on the new policy to create the new policy. If you want to use the existing access control policy, you can very well do that as well. Here, I'm creating a new policy. Provide the name of the policy here and the default action. So by default, it's block all traffic. So if the specific traffic flow doesn't match any of the rules in the access control policy, it will apply the default action. You can add target devices here, but for now, we don't yet have the devices, so we can skip this for now. And click on Save. So we've created the policy and we need to add a rule. Just for this demo purpose, let's add an LOL rule. Disclaimer, this LOL rule is not at all recommended. I'm just adding this in the lab environment. That too, just for the demo purpose, right? So you should add rules based on your network and the use case. So click on Add Rule, provide the name, and enable logging here, and click on Confirm. And click on Apply and save it. Remember the name of this access control policy. We will later use this while deploying the cluster. You can also get the name from FMC anytime, by the way. So yeah, we are done with creating the policy. One another thing that we need to do on the FMC before moving further is to create the users. To allow the cluster to auto-register with Management Center, we need to create two users with admin privileges on FMC that can use the REST APIs. Click on the settings icon on the top right corner and click on Users. Click on Create User. Provide the first username and the password. Provide the admin privileges to this user and click on Save. Similarly, click Create User again to create the second user and provide the name, password, and admin privileges and click on Save. Okay, that's all we need to do on the FMC. In step 3, now let's understand and modify the templates. On your local machine, open the GitHub repository that we downloaded in step 1. Okay, so this is the repository that we downloaded. As you can see, we have multiple folders, each representing a different CloudFormation template for various deployment models and components. These templates help us deploy a Cisco FTDv clustering solution for AWS that enables automated deployment and management of firewall cluster across multiple availability zones. So these are different folders here. And let's understand what all these are doing. Here, if you see, this is the PDF, ftdv cluster.pdf. It's a documentation about the solution. You can refer this if you have any questions while deploying. And here this readme.md file. So this is like a main documentation with setup instructions, prerequisites, and deployment steps. And this is one another folder, Lambda Python files. So this folder contains all the Python code files for AWS Lambda functions that orchestrates the cluster, right? And if you see, this is a templates folder, and files in these template folders are what we are going to start with. As you can see, we have two different files. One is infrastructure.aml file. This AML file is used to create VPCs, subnets, security groups, S3 buckets, and other foundational AWS resources. If we take a look at this file at a very high level, you can see here you can provide inputs for various parameters based on your requirement. This templates also has the default values. So for example, if you see the first parameter is cluster name, it has information like description, like what it means and the type of the input you should provide, minimum and maximum length of the input, and the default value. Similarly for cluster number and VPC CIDR, and we have this default CIDR here, and the number of availability zones that you would want your network to spread across and the default value, right? So similarly for all the other parameters, you can see all the details and provide the input according to your deployment use case. So here I'm not changing any of these values. I'm going with the default values. If you go further and expand this resources section here, you can see various resources getting deployed like VPCs, multiple subnets across multiple availability zones, internet gateway and the route tables, routes, access control lists, security groups, route table associations, S3 buckets, etc., etc. Right? So these are all the different resources that we are deploying using this template here. So you can modify this template based on your requirement and the use cases, as I mentioned. So this is the first template where we are deploying various AWS network resources and the underlying infrastructure. So, and the second template is deploy ngfw cluster.aml. So this is a template for deploying FTDv cluster with auto-scaling groups, Lambda functions, and cluster logic, gateway load balancer endpoint, etc., etc. So you can expand on any of these sections and see what is there inside each section. And here the conditions, metadata, and what are all the resources getting deployed, Lambda layers, or the user notifications, Lambda functions, VPC endpoint service, gateway load balancer endpoint, manager Lambda, etc., etc. Right? You can expand on these sections and see what is being deployed for you using this template. So if you are interested, and also an automation geek like me, you can go through these CloudFormation templates and try understanding what these templates are deploying and tweak them as per the requirements. So just to quickly summarize, this infrastructure.aml file deploys the required network resources and deploy ngfw cluster.aml file deploys or will create the Lambda functions, scaling logic, firewalls, auto scaling group, load balancers, target groups, etc., etc. So these are the two templates that we will be uploading to the stack and launch the stack in AWS. Right. So one another thing that you need to do here is here in the Lambda Python file folder, we have this configuration.json file, right? So where you need to provide the details of your FMC, such as your FMC IP address, licenses, access control policy details, etc., etc. So this is the access control policy that we just created on the FMC. So I provided the name of the access control policy here. You can also you need to provide the values for registration ID, NAT ID, and FMC IP address, performance tier of FTDv, and the licenses that you want to apply to your FTDv, right? Um, so provide all the details here. You can provide the FMC IP while launching the stack as well. So once you edit all these details and provide the values, save this file. Yeah, so these templates provides a complete infrastructure as code approach for deploying a highly available auto-scaling Cisco Secure Firewall threat defense cluster in AWS with multi-availability zone support, right? So we've got the templates ready on our local system. We also understood how these templates work and what these templates are deploying, and we can modify these scripts with different parameters based on our requirement, right? Okay, so now moving further, in third step, we understood the templates, we modified the templates. In fourth step, we'll create the zip files. To do this, we need to run a couple of commands. So I'm using an Ubuntu box with Python installed to run the commands. You don't need to worry about remembering these commands or the steps. I'll provide the document link in the description with all these commands, right? So first, let's create a requirements.txt file with all the required Python package details and save it. Now, run this command to create a cluster layer.zip file. And once you have this zip file, so if you see here, we have cluster layer.zip file created. So now we have this zip file here. So let's copy this to our local machine using SCP or a similar tool. So here, let's use SCP. Let's copy this zip file to Lambda Python's files folder. Okay, so here if you see in Lambda Python files folder, we have this zip file here. So now on our local machine in the same repository that we downloaded, run this Python command. So Python 3 make.py build. So this command will zip the Python files and copy those to a target folder. Okay, with that step, we created the required zip files. Okay, now we have everything ready. Let's move on to the step 5. Onto AWS and launch the first stack to deploy the required network resources. Okay, this is my AWS account. Here, search for the cloud formation or click on the cloud formation on the dashboard and click on create stack and choose with new resources. Choose an existing template and here click on the upload template file and choose the file and select infrastructure.aml file and click on next. Here, provide the stack name. Under parameters, most of the parameters are pre-filled with the default values from the script. You can modify these values here if required and provide the cluster name, cluster number of availability zones that you want to use and choose those availability zones here. A VPC CIDR range, subnet names, CIDR ranges, provide all this information here like different subnet names, different CIDR ranges and all of the information. And once you provided all the details here, click on next. So I'm deploying with the default values, but you can edit these here, right? I'm not editing any of these. Here, after you clicking on the next, you can configure the stack options here and can change these various settings like how you wanted to roll back the resources if the stack deployment failed or etc etc. And once you check all of these stack options, you can click on next. Here, review all the details you provided in the previous steps and click on submit. It will start creating all the resources. You can track the progress and see what are all the resources getting deployed and what are all the resources that are deployed so far and what is it deploying right now, etc., etc. Right? Now the state is create in progress. So once the state is create complete, you can click on the resources to see all the resources that this stack deployed. And you can see all the outputs from the stack deployment as well, right? Now here, before moving to the next step, we need to copy this S3 bucket name from here, or you can remember this name, right? Okay, in step 5, we deployed the stack to deploy all the infrastructure using our infrastructure.aml template, right? We also deployed one S3 bucket using that stack. In step 6, we'll be uploading all the zip files that we created in one of the previous steps into the S3 bucket, right? Let's again go to the AWS console. On AWS console, search for S3 or click on S3 from the dashboard. And here, search for the S3 bucket name that our stack deployed in the previous step. And this is the S3 bucket that our stack deployed. So click on that and click on upload and upload the zip files, right? And add the files, these 4 files that we have here, and choose these 4 zip files from the target folder into the S3 bucket and upload them into the S3 bucket. And once it's uploaded, click on close. So we've uploaded all the zip files that we need onto the S3 bucket so that our Lambda functions can use these zip files. Okay, we've deployed all the network components needed in step 5 and uploaded the zip files in step 6. We uploaded the zip files to S3 bucket so that our Lambda functions can use those files. Now in step 7, let's launch another stack to deploy the firewall cluster with Autoscale. As we saw at the very beginning of the video, we are using 2 YAML files. One is to deploy the required underlying network resources, which we just deployed, and the other stack that we are launching now will deploy the firewall cluster, load balancers, target groups, Lambda functions, autoscale groups, etc., etc. Again, on AWS console, search for CloudFormation or click on CloudFormation on the dashboard and click on Create Stack and choose with new resources. Make sure that you choose an existing template and here click on upload a template file, right? And click on choose file and upload deploy ngfw cluster.aml file and click on next. Provide the stack name, same as the previous stack. Some of the parameters are pre-filled, and we need to provide values for the other parameters and edit the existing values if required. So cluster group name prefix, cluster name, size of the cluster, as in how many FTDv devices that you want to deploy as part of this cluster, and number of availability zones, and mention those availability zones. And you can mention email ID to receive the notifications, and provide the S3 bucket name that we deployed using the first stack, which contains the lambda zip files, right? So while deploying this stack, we'll be choosing and using the resources like S3 bucket, VPCs, subnets, security groups, etc., that we deployed using the previous stack. So here we need to select the VPC that we deployed using the infrastructure stack. And similarly, while launching the infrastructure stack, it also deployed various subnets like management subnets, inside subnets, Lambda subnets, CCL subnets across multiple availability zones, right? So here we need to choose all those pre-deployed subnets. Here we need to choose the security groups. And once that's done, let's do the gateway load balancer configurations. Here we should choose yes if you want the stack to deploy gateway load balancer endpoint, or if you want to deploy it manually, you can choose no and move forward. Right here, I want the stack to deploy the gateway load balancer endpoint for us. So I'm choosing yes. So you need to provide the details of application VPC and subnet where you want this gateway load balancer endpoint to be deployed. And I spoke about target failover in the first part of the series. If you haven't watched that video, I would highly recommend watching that before this video. But just to give you a quick recap, as you see here, we have two options. One is rebalance, the other one is no rebalance. So basically, rebalance means gateway load balancer makes sure that it sends all the existing and new traffic flows to the healthy instances in a target group. If in case one of the nodes failed or became unhealthy, gateway load balancer will rebalance or redistributes that existing flows to the healthy node, while ensuring new traffic flows will also go to the healthy nodes, right? Whereas in case of no rebalance, gateway load balancer will keep sending the existing flows to the unhealthy nodes, but sends the new traffic flows to the healthy nodes or targets, right? Here we need to choose so here we need to provide details of FTDv like NGFW, instance type, license types. Either you can do BYOL, by your own license, or pay as you go model, and provide AMI ID for the FTDv. Here this AMI ID is different for different regions and for different versions. So before launching the stack, get the AMI ID of FTDv based on the version that you want to deploy and the region, and have it handy, and provide the MI details when the stack is asking for it, right? And provide the password for firewalls. And here we'll provide FMC details such as FMC IP address, device group name. And if you remember, we created two users on FMC with admin privileges, right? So one is FMC API and the other username is FMC metric user. So here provide those usernames and the passwords. And these are the threshold values. You can edit these if you need to and click on next. Look at these various stack options and acknowledge these at the end, right? And click on next. Review all the details and the parameters inputs you provided. And if everything looks good, click on submit. It will start launching the stack and it starts deploying various resources, right? You can track the progress of the stack deployment and see what are all the resources getting deployed, right? So after some time, once the status of the stack is create complete, you can see the stack info and can see the progress of various events, and also all the resources that are deployed using with this stack, right? And parameters, templates, etc., etc. You can see everything regarding the stack from this page. Okay, now we've deployed the FTDv cluster with Autoscale in AWS. So as a last step, let's validate the deployment. With the templates, we've deployed this security VPC and subnets inside that: security VPC, route tables, security groups, cluster with FTDs, gateway load balancer, and gateway load balancer endpoint in specified application VPC. So whatever you see in this red boxes are deployed by the templates, and this is on the left side is your application or the spoke VPC um, that you want to secure, right? So these application VPCs are not deployed using the templates that we launched now. So let's go to the AWS console and validate the resources that we deployed using the CloudFormation templates. Okay, let's start with VPC. So this is a VPC that we deployed using the templates. If we see the VPC resource map, we can see the resources in that VPC. It is only showing some of the resources here, but we deployed more than this, right? You can explore more while you deploy this VPC. But we have the subnets deployed across multiple availability zones and the route tables associated with these subnets, and also internet gateway, NAT gateway, VPC endpoint, etc. And not only this, we also deployed the gateway load balancer endpoint, target group, etc. Right? And also let's go ahead and check the gateway load balancer as well. So this is the gateway load balancer that our templates deployed. If we click on that, it is forwarding the traffic to this target group. If we expand this, we can see the targets and see the status of health of these instances. Gateway load balancer also do the health checks of the FTDs and make sure that the traffic is going to the healthy instances only, right? It won't send the traffic to unhealthy instances. Um, Templates also deployed autoscale group for the autoscaling logic. So this is the autoscale group. Here we can edit the autoscale group and change the minimum and maximum and desired number of instances, right? So that you would like to have in your cluster as needed. I'll show you the full details and how this works in the next video. Here in this video, the main goal is to deploy the cluster with autoscale. Once the FTDs are up and running in the AWS, Lambda functions automatically onboards these FTDs into the FMC, right? Okay. In this video, we have successfully deployed the FTDv cluster with Autoscale in AWS and also validated the deployment, right? We've come to an end of our video. Just to summarize, as I mentioned at the very beginning of the video, the main goal of this video is to show the deployment process of the FTDv cluster with Autoscale in AWS. We deployed it and we validated the deployment. So, and also I know that we didn't go through the operational details. We didn't look at the Lambda functions, logs, etc. Let's do that in the next video. I don't want to make lengthy videos, so this video is only for the deployment process. And I'll record another video that will be the last one for the clustering in AWS, where we'll look into the details of how the traffic flows in different directions like ingress, egress, and east-west, and also look into how the autoscale group works and what are the various Lambda functions are doing. And we'll look at all the configurations on the FMC also, right? I hope this step-by-step walkthrough helped you understand how you can deploy the FTDv cluster in AWS and helped you deploy the cluster. Let's meet in the next video with more details and configurations. Thank you for watching. See you soon in the next video.